Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. My name is Azah Abdul Aziz. I'm going to talk about the upconversion nanoparticle in biomedical application. So these are the contents for today's talk. As an introduction, UCNP or upconversion nanoparticles has been discussed as promising alternatives to organic fluorophores and quantum dots in the field of biomedical imaging or biomedical application. Okay, what is nanoparticle? It is an optical nanomaterial co-doped with lanthanide or rare earth ions that efficiently convert low-energy photons in the near-infrared into high-energy photons in the visible, normally in red, green, and blue colors. It is a process through a nonlinear process called multiphoton transition. So if you say in the periodic table, you can see that the lanthanide group is in this position. So it is spanning from atomic number 57 to 71. Okay, the main composition of the UCNP is the host matrix and two dopant ions, which is sensitizer and activator. The choice of these three elements would determine the unique properties of the UCNP. So what happens is that when the near-infrared radiation eliminate the UCNP, what will happen is that the photon is absorbed by the sensitizer. So from there, because the sensitizer and the ion, the activator ions, they have quite similar intermediate energy states, so that the ytterbium ions can be easily transfer the energy to the neighboring ions, which is the activator. So as you can see here, this is the excitation. The sensitizer absorbs the photons of the near infrared, and what happened is that the energy is transferred to the neighboring energy level. So there are some more what we call that, the energy absorption and relaxation happening in here, and at the end this activator will release photons which is emitted at visible region in a blue color, green, and red. Okay, so the graph here, the diagram here shows that the quantum yield, is excellent at a wavelength 540 nanometer. If you can see here, this emission is quite strong in the erbium ion, whereby in the thulium ion, it is the quantum yields are excellent, are bright at 800 nanometer. Okay, these are the synthesis method. Okay, thermal decomposition, hydrothermal, microemulsion, and sol gel to synthesize the UCNP. And the unique properties, these are the list of unique properties, mainly the excellent, the photo illumination, the photo luminescence is excellent, no fluorescence background, high penetration depth, no photo bleaching, and so on. Okay, this process, the whole process, bear in mind, for normal fluorophores such as quantum dot, it uses the Stokes shape. The UCNP, on the other hand, use anti-Stokes, where the N energy is higher than the absorbed energy. Okay, the emission is higher than the absorbed energy. These unique properties makes the UCNP is the excellent candidate for biomedical application. Okay, the synthesized UCNP upconversion nanoparticle is not biocompatible. We need different surface modification in order to get ready for bio imaging or bio treatment for any biomedical application. We have to have a different surface modification. So these are the methods for surface modification. At the end, we need to do the optimization and field testing in order to get water-soluble, functional, biocompatible, high chemical stability, and low toxicity. So to get ready to be used in biosensing, imaging, and the treatment. Okay. In biomedical application, there are three main areas that apply UCNPs in immunoassay, the two-photon microscopy, multimodal imaging, drug delivery, optogenetics, PDT, PTT, and gene therapy. So these are the work done by the Matiskinen and co-workers to detect the anti-HIV antibodies using the UCNP. This work is done by the Chang and co-workers. It used the UCNP for multimodal. If you see here, UCL, upconversion, luminescence, and MRI. And they use that for the treatment as well, thermal therapy. And these are the morphology. And for this one, Chen and co-workers used the UCNP, upconversion nanoparticle, for brain stimulation for the what we call that, neurological disease. So these are the challenge and future possibilities that still have room for further investigation. So with that, I thank you very much for listening. Assalamualaikum warahmatullahi wabarakatuh.